So yeah, we are AI Shields team. Our goal is to build a middleware so that the Gen AI and LLM is trustworthy and secure. Remember that there is a list of 10 known security vulnerabilities to Gen AI, and in a couple of weeks, we're focusing on 5 of them. And most of our work this week was researching on the problem itself and coming up with a solution and implementing quick and dirty implementation so that we see that it works and can be integrated. Looking at details, right? When it comes to sensitive information disclosure, right? The goal was to identify the personal data and to sanitize it, right? To anonymize it. So I pushed the rule-based version, which is based on regular expressions in Python. It was tested, and about 10 patterns were recognized. However, my goal as a next step is to use a pre-trained model, which is an named entity recognition model using Hugging Face, and fine-tune it with a larger data set so that I come up with a model which is context-aware, and that's the main goal of this task. Now I'm giving it over to James, please.
Great. So my part of the project deals with the idea that a lot of the requests that are sent to these LLMs are quite computationally expensive. And so this is my model denial of service data model. And as for the next slide, we deal with the problem that these create bottlenecks and decrease service for the other users. So the progress that I have made involves implementing a current rudimentary rate limiting tracing method using a basic Flask app, which just detects network traffic to a server and blocks out specific methods from executing. So as you can see here, the rate limit was exceeded after a query 6 was made, so we blocked out from that. And so the next step would just be just developing more sophisticated tools using ML models to detect deviations from normal usage patterns and limit those.
Okay, for insecure output handling, we focus on the cross-site scripting kind of stuff, and this kind of problem could come from the HTML, JavaScript, CSS, and URL content included in the output. The progress we have so far is to include output encoding for all this kind of stuff and conduct HTML sanitization at the end, and also identify the difference or changes made in this sanitization process. Our next step including to generate output handling report storage. Yep.
For the security risk of over-reliance, the problem is that lack of proper sourcing can lead people to believe false information given by the language models. So far, I implemented a rake algorithm to consistently determine key phrases from text, and then I can use this to perform an automatic web search. And the next steps is to determine the models that are best suited to find textual context and compare output statements with external sources. And there's a data output example on the next slide, but we can continue.
Yeah. And so finally, for last security risk, prompt injection is users are trying to do malicious actions from large language models and bypass the guardrails that they set up. So they usually these attacks have a structure of like a framework and a request. So like the framework will usually be something to subvert that. So for this week, I trained a random forest classifier to identify prompt injection based off the data set I got on Hugging Face. It performed okay. So the next steps is I want to try to, instead of just identifying prompt injections, I want to identify the frameworks and the malicious request to hopefully maybe eventually take an ensemble learning approach.
Thank you very much. That's it from our team.